You know, people always wonder what a unicorn looks like before it's a unicorn. Well, it usually looks like a solution to a problem most of us don't even see coming yet. And that's what we're talking about today, Small Modular Reactors, or SMRs. But listen, this isn't just another story about a new energy source. This is about the key, the only key, that might unlock the entire future of AI, using a power source that's literally been waiting for billions of years. So yeah, let's get into it. And if you're looking for a starting gun, here it is. This comes from Jensen Huang, the CEO of NVIDIA. Now, when the guy who is basically building the engine of the AI revolution says something like this, you have to understand it's not a prediction, it's a diagnosis. He sees a massive, massive roadblock coming, and he's pointing at the one thing he thinks can actually clear the way. He's not even talking about data centers anymore. Did you catch that? He's calling them gigawatt factories. And that right there is the whole game. For the first time, maybe ever, the thing holding back our technological progress isn't how fast our chips are, it's not our algorithms, it's just raw brute force power. You see, AI data centers are creating a whole new category of energy demand. It's so big that our current grids, well, they just weren't built for this. This isn't some small problem we can tweak our way out of. For AI, this is an existential threat.
So, if the problem is that fundamental, the solution has to be just as fundamental. And this brings us to the core idea, the whole reason we're talking about this, the concept of compressed potential. We're not looking for a slightly better solar panel or a bigger battery here. We're talking about tapping into a fundamental force of nature that has been sitting there, just waiting for this exact moment in history.
And just think about the scale of this for a second. I mean, really think about it. Every single atom of uranium on this planet was forged in the heart of an exploding star billions of years before the Earth even existed. And for 4.5 billion years, that incredible stellar energy has just been locked away, patiently waiting for the right set of conditions to finally let it out. I mean, if that's not the definition of stored potential, I don't know what is.
And if you want to make that real, look at this number, 3 million to 1. That's not a metaphor, that's just physics. A single kilogram of uranium holds the same energy as 3 million kilograms of coal. It's not a little better, it's not twice as good, it's a different category of reality. And for all these years, the problem was never the potential of the atom, it was that our ways of unlocking it were frankly big, clumsy, and kind of dangerous.
And this right here shows you the complete shift in thinking. On the left, you've got the old way, these massive custom-built projects that took a decade and had terrifying failure modes. But on the right, you have the SMR model. They're built in factories, like an airplane, in just a couple of years. And here's the kicker. Instead of complex active safety systems, they rely on passive safety. That means the laws of physics themselves, things like gravity and convection, are what stop a meltdown. It's not an upgrade, it's a total reinvention of the whole idea.
Okay, so this all sounds great on paper, but how do we know this is actually happening? Well, you just have to look at what the tech giants are doing. When you see companies that are fierce, bitter rivals, I mean, they fight over everything, and they all suddenly start making the same huge bet on the same technology, well, that's not a trend, that's a necessity. So let's start with Amazon. The two key words from their cloud CEO are carbon-free and able to scale. See, lots of things are carbon-free, and some things can scale, but finding something that does both at the level AI is going to need for decades, that list of options gets real small real fast. Then you've got Google, and notice, they connected directly to AI. They're not just saying they need more power, they're saying they need to accelerate a new technology to handle AI's demands. They're not just buying a product, they're investing in the factory because their entire business model is going to depend on it.
And then there's Microsoft. Their president, Brad Smith, takes it a step further. He doesn't call it an option or an opportunity. He calls it a critical future enabler. I mean, stop and think about that. A software company is calling nuclear power a critical enabler for its future. If that doesn't tell you a fundamental shift is happening, nothing will.
And hey, talk is cheap, right? But this is where they're putting their money. We're not talking about small pilot programs. Amazon is targeting 5 gigawatts. Microsoft is signing deals for hundreds of megawatts. These trillion-dollar companies are building their own internal nuclear teams. You don't do that for a side project. You do that when you see a fundamental threat to your future growth.
So this is the key takeaway. When you see Amazon, Google, Microsoft, and Oracle all coming to the exact same, very expensive conclusion, it's not because they're all just following each other. No way. It's because each of them, on their own, ran the numbers and slammed into the exact same wall, the laws of physics and the limits of energy density.
Now, whenever a huge industrial shift like this starts, the tech companies are the first to see it. But it's only a matter of time before the financial markets and the government start to pick up on the same signal. And that, folks, is exactly what's happening right now.
Just look at this chart. This is what it looks like when smart money starts to figure things out. Yeah, the S&P 500 is having a fantastic year, but the nuclear sector, it's more than doubling it. This is the financial signal that the big money is getting into position before this becomes obvious to everyone. They can see that compressed potential starting to unwind.
And at the exact same time, look what the government is doing. The policy is making a huge shift away from just studying the problem and toward actually building the solution. The Department of Energy is handing out hundreds of millions in deployment funding. That's not money for white papers. That's money to pour concrete and build actual reactors. It means SMRs are now being treated as critical national infrastructure.
So, what happens when you put it all together? You've got the pull from the tech giants, you've got the push from the financial markets, and you've got the green light from the government. What you get is a timeline where all this potential finally starts to look like reality.
What's so wild is how all these different timelines just magically seem to converge. Microsoft's power deal starts in 2028, Google expects its first SMR online by 2030, and where does that land us? Smack dab in the middle of Jensen Huang's 6 to 7 year window. When the guy making the chips and the companies using the chips all point to the same few years, it starts to feel less like a guess and a lot more like a schedule. But okay, let's be real. This isn't a done deal. There are absolutely risks here. Execution is everything, and we still have to see if those factory-built cost savings actually happen at scale. Public and political support is fragile. One bad incident anywhere could change everything. And of course, timelines can always slip. These are major hurdles for sure, but what they don't change is the underlying need. The physics problem doesn't go away.
Which really just leaves us with one last big idea. We're talking about an energy source that was created in a dying star. It sat dormant in the ground for billions of years, just waiting for a species to come along that could understand it, and then waiting for that species to create a problem so huge that it would finally desperately need it. It feels like all the pieces are finally falling into place. So the only question left is, are we the ones who are finally going to turn the key?